Hi students, welcome to physics classes. Today we'll discuss refraction of light at plane surfaces. Class 10 physics. Bits we will discuss. I already uploaded bits from heat lesson. Now I am uploading refraction of light at plane surfaces. Now first question is, if N21 refractive index of second medium with respect to first medium equal to 1.33, find V1 by V2. Now here we know N21 equal to N2 divided by N1. N21 equal to N2 divided by N1, and the refractive index is inversely proportional to speed of light. So N21 we can write N2 by N1, then that is equal to V1 by V2. So N2 by N1 equal to V1 by V2, that is equal to, in the question they given N21 1.33, that is equal to V1 by V2. V1 by V2 equal to 1.33. If they asked V2 by V1, we should write 1 by 1.13. 1 by 1.33. Next, second question, the speed of light in a medium is low when refractive index of the medium is. I already told you speed of light is inversely proportional to refractive index. If refractive index is more, speed of light is less. If refractive index is less, speed of light is more. So the answer is more or high. If the medium is having more refractive index, speed of light is low. If the medium is having less refractive index, speed of light is more. Next question. Light travels in vacuum with a speed nearly equal to dash meter per second. In vacuum, speed of light is 3 into 10 power 8 meter per seconds. 3 into 10 power 8 meter per seconds. And it is denoted by letter C. Speed of light is in vacuum 3 into 10 power 8 meter per seconds, and it is denoted with the letter C. Next, he given one table. Refractive index of medium A, B. Medium A refractive index is 1.44 and B is 1.71. Now the question is, in which medium speed of light is more? In the first question only we seen if a medium has more speed of light, that will have less refractive index. More speed of light, less refractive index. Now here speed of light is more for the medium which has less refractive index, that is 1.44 for A. For A, refractive index is less, so that it has speed of light is more. Remember, which has less refractive index, that will have more speed of light. Now which has less optical density, Now here the medium which has less refractive index will have less optical density. Medium which has less refractive index has less optical density. So here A has less refractive index, it will have less optical density. Next, a lemon kept in a glass of water appears to be dash than its size. Lemon kept in a glass of water appears to be dash than its size. Now when the lemon is kept in a glass of water, it appears bigger than its size, larger than its size. Next question, the process of changing speed at interface. What is meant by interface? Interface means separation of two mediums. When we take air, water, that separation, air and water, is known as interface. Now the process of changing speed at an interface when light travels from one medium to another medium, resulting change in its direction. When light traveling from one medium to another medium, speed of light changes. Speed of light changes, resulting change in direction is known as refraction of light. Next, the process of refraction involves bending of light ray, except when it is. Now light ray while traveling from one medium to another medium changes its path. Not in all the situations, except in one situation. That is when it is traveling along the normal. When it is traveling along the normal, light ray will not changes its path. It will not bend. Next question, if light ray enters from rarer medium to dash, then refracted ray moves towards the normal drawn at the interface of separation of two media. Now when light ray traveling from rarer medium to denser medium, it bends towards the normal because speed of light decreases, so it bends towards the normal. When light ray travel from dash to rarer medium, it bends away from the normal. Reverse previous case. When light ray traveling from denser medium to rarer medium, it bends away from the normal. When light ray propagates through one medium to another medium, expressed in terms of. When a light ray propagates through one medium to another medium, is expressed in terms of refractive index. Is expressed in terms of refractive index. In the experiment, refraction through glass lab. In the experiment, refraction through glass lab, what do you observe in the deviation produced by glass lab? Now, when light ray traveling through the glass lab, it first, when it is traveling from air to the glass, bends towards the normal, and the glass to the air bends away from the normal. So balanced. It travels straight, no deviation. Deviation is 0 degrees. The speed of light is smaller than c in other transparent medium. In all other transparent medium, speed of light is smaller than c. C means speed of light in vacuum. C means speed of light in vacuum. Now absolute refractive index n equal to speed absolute refractive index n equal to speed of light in vacuum by speed of light in medium, or c by v. C means speed of light in vacuum, v means speed of light in any medium. Refractive index depends on dash and dash of light used. Refractive index depends on nature of material, what material we have used, and wavelength of light. Nature of the material and wavelength of the light. Refractive index of second medium with respect to first medium. Refractive index of second medium is n2 and the refractive index of first medium is n1. So refractive index of second medium with respect to first medium n21 equal to n2 by n1, or we can write it is v1 by v2, v1 by v2. Relative refractive index n12. n12 means refractive index of first medium. Refractive index of first medium with respect to second medium is equal to refractive index of first medium with respect to second medium equal to refractive index of first medium divided by refractive index of second medium. Remember, if they given n21, n2 by n1. If they given n12, n1 by n2. n12 means refractive index of first medium with respect to second medium. If they given n21, n21 means refractive index of second medium with respect to first medium. The formula for critical angle is critical angle, or they will ask you relation between critical angle and refractive index. Relation between critical angle and refractive index. Sin c equal to 1 by refractive index, or 1 by n. 1 by refractive index or 1 by n. We observe that at certain angle of incidence, the refracted ray does not come out but grazes at the interface separating air and glass. This angle of incidence is known as critical angle. At critical angle, light ray will not enter into rarer medium. It won't come out from denser medium. It grazes at the interface. Remember that it takes place when light ray traveling from denser medium to rarer medium. Denser medium to rarer medium. Next, at critical angle of incidence, angle of refraction is, in previous question we seen, refracted ray does not come out but grazes at the interface. Grazes at the interface. So angle of refraction is 90 degrees. Angle of refraction is 90 degrees. Next, doing experiment with the glass lab, vertical shift is independent of. Vertical shift is independent, not dependent of options they given: object distance from the glass slab, refractive index of the glass slab, thickness of the glass slab, nature of surrounding medium around the glass slab. Now the answer is object distance from the glass slab. Wherever you kept the glass, wherever you kept the object, vertical shift is same. Wherever you kept the object, vertical shift is same. So it is independent on object distance from glass slab. Next, a light ray incident on air liquid interface at 45 degrees is refracted at 30 degrees. So the refractive index of liquid is options they given: angle of incidence is 45 degrees and angle of refraction is 30 degrees. So to find refractive index, he given hint uses Snell's law. So to find refractive index, even they didn't given Snell's law hint, we have to take Snell's law. Sin I by sin R equal to refractive index constant. So n equal to sin I by sin R. Sin I value 45, R equal to 30. Sin 45 by sin 30. We know sin 45 is 1 by root 2 and sin 30 is 1 by 2. See clearly, 1 by root 2 whole divided by 1 by 2. Now if 2 is going up, 2 by root 2, root 2 will get cancelled in the 2 root 2 times. So answer is square root of 2, B option. When light ray travel from water to air, when light travel from water to air means denser to rarer. Now see the options what they given: bends away from the normal, bends in travels in straight line in the same direction, bends towards the normal, none of the above. Now the answer is when light ray traveling from denser to rarer bends away from the normal. Option A is correct answer. Next, given like statements P, the light travel from rarer medium to denser medium, it bends towards the normal. When light travel from rarer to denser medium, it bends towards the normal. It is correct statement. Next, Q statement: when light ray travel from rarer medium to denser medium, speed of light increases. No, speed of light decreases. Now P statement is correct. Only P is true, Q is false. What is wrong in Q? The light ray travel from rarer medium to denser medium as the speed of light decreases. When it travel into denser medium, speed of light decreases so that it bends towards the normal. Next question: the refractive index of glass with respect to air is 2. Refractive index of glass with respect to air is 2. The critical angle of glass air interface is, we know the formula for critical angle: sin C equal to 1 by refractive index. Refractive index they given 2. So sin C equal to 1 by 2. 1 by 2 will come in sin 30 degrees. Sin 30 degrees. So sin C equal to sin 30 degrees, then C equal to 30 degrees. Next, the speed of light in a medium 1.25 into 10 power 8 meter per second and the speed of light in air 3 into 10 power 8 meter per second. Then what is the refractive index of X? Now we know the formula for refractive index: N equal to C by V. They given options also: 2.4, 0.4, 4.2, 3.75. Now we have the formula for refractive index: N equal to C by V. C they given 3 into 10 power 8 by 1.25 into 10 power 8. 10 power 8, 10 power 8 cancel. 3 divided by 1.25 equal to 2.4. So answer is A. Next, suppose you are inside a swimming pool. Your friend is standing on the edge of the swimming pool. Your friend appears to be. Your friend is outside. You are inside. So your friend appears taller than actual height. They appear taller than actual height. So for your friend, you appear shorter than actual height. Remember, the person who is inside the water appears shorter. The person who is outside the water appears taller. Next, the light must travel from denser medium to rarer medium to form total internal reflection. Yes, to form total internal reflection, light ray should travel from denser medium to rarer medium. Next, the angle of incidence is greater than critical angle for the pair of media. So here, to form total internal reflection, angle of incidence is greater than critical angle. So both are true. Answer is A. Both are true. Next, which of the following statement is true? When light travel from one medium to another medium, speed of light changes. Yes. When it is traveling from either rarer to denser or denser to rarer, speed of light changes. When light travel from one medium to another medium, frequency of light changes. No, frequency never changes. Frequency is always constant. Very important bit. When light traveling from one medium to another medium, which of the following quantities will not change? Like that, they will ask some questions. Frequency will not changes. So correct option is only X. A. Next, the refractive index of medium depends on. Refractive index depends on nature of the medium, nature of the substance, wavelength of the light, frequency. No, on frequency it won't depend. Only nature of the substance, wavelength of light used, it will depends. Next, beauty of nature is made apparent with light. Because of light only we are able to see all objects around us. So it makes beauty of nature is made apparent with light. Next, we observe that coin kept at the bottom of the vessel filled water appears to be, when we keep a coin in the water, it appears raised. It appears raised than actual height. When a thick glass slab is placed over some printed letters, the letters appears to be, when viewed through the glass slab, raised. When we keep a glass slab any letters, printed letters, they appears to be raised. The speed of light changes when the light propagates from one medium to other medium, other transparent medium. Speed of light changes. Refractive index gives us an idea of how fast or how slow light travels in a medium. How fast, how slow in a medium. The critical angle of a diamond is. Next, when light ray travel from denser medium to rarer medium, the angle of incidence is greater than critical angle. Angle of incidence is greater than critical angle. The light ray reflected into a denser medium at interface. Light ray is reflected into denser medium at interface. This phenomena is called total internal reflection. This phenomena is called total internal reflection. Next, during refraction, light follows Snell's law. What is Snell's law? N1 sin I equal to N2 sin R. N1 sin I equal to N2 sin R. Which of the following statement is true? First one, when light passes from rarer to denser medium, angle of incidence is more than angle of refraction. When light ray traveling from rarer to denser bends towards the normal, so angle of incidence is more than angle of refraction. It is correct. When light ray passes from rarer to denser medium, V1 is less than V2. V1 is less than V2. It is wrong. When light travel from rarer to denser, V1 is the speed of light in rarer medium, V2 is the speed of light in denser medium. V1 is more than V2. So only X is true. Only X is true. If V1 is greater than V2 they given, then second one also correct. Dash is an optical illusion where it appears that water has collected on the road at a distant place, but when we got there, we don't find any water. This is mirage. Mirage is an optical illusion. It will appear some water collected on the road, but if we go there, we won't find any water. Formation of mirage is best example where dash of a medium varies throughout the medium. Refractive index. Now, as we see, temperature of the air at ground is more. As we go higher altitude, temperature is less. So, refractive index also changes. Higher altitude has more refractive index. As coming down, refractive index will be decreases. So higher layers of air is acts as a denser medium, lower layers of air is acts as a rarer medium. So light continuously bends away from the normal and it takes reflection itself in the air. So it is total internal. It is taken as example of total internal reflection. What it is? Mirage. So refractive index of air changes. Next, which of the following statement is true? The reason behind the shining of diamond is scattering of light. No. Reason behind the shining of diamond is total internal reflection. The total internal reflection is the basic principle behind the working of optical fiber. Yes, total internal reflection is the basic principle behind the working of optical fibers. Only Y is correct. B. Next, we know that refractive index of air increases with density. More density, more refractive index. Lesser density, lesser refractive index. The cooler air at the top has dash refractive index than hotter air just above the road. We discussed cooler air at higher altitude, hotter air just above the road. Cooler air has more or greater refractive index. More or greater refractive index than hotter air just above the road. Next, observe the given table, answer the following questions. Material, medium, refractive index. Ice, diamond, benzene. Ice refractive index is 1.31, diamond 2.42, benzene 1.50. Now the question is, which medium has highest optical density? Which medium has highest optical density? Which medium has more refractive index? More refractive index that will have more density. That is diamond. Next, which medium has least optical density? Which medium has least optical density? Which has low refractive index that will have least optical density? That is ice. Okay, thank you for watching. Please subscribe for more updates.